For decades, humanity has looked at the red dot in the night sky and wondered, could we live there? Mars, our planetary neighbor. It's cold, it's dry, and it's covered in rust-colored dust. Yet, every few years, a new announcement pops up. We're going to Mars. Colonize Mars by 2050. But let's stop for a second and ask the real question that often gets skipped in all the hype. Not when, but how. And more importantly, is it even possible? Today, we are going to put aside the sci-fi movies and the billion-dollar rocket plans. We are going to look at Mars through the lens of a biologist, a physicist, and a survivalist. We are going to break down the brutal reality of living on a planet that is essentially a frozen desert with no air. Is it a future home for humanity, or just a grave waiting to happen? Let's find out. The atmosphere, the invisible killer. Let's start with the thing you need every 5 seconds: air. On Earth, we take our thick, cozy atmosphere for granted. It's like a warm blanket that also happens to be full of oxygen. Mars, however, has a blanket that is torn, thin, and toxic. The Martian atmosphere is about 100 times thinner than Earth's. To be precise, it has less than 1% of the pressure we have at sea level. If you stepped onto Mars without a spacesuit, you wouldn't just hold your breath and pop like in the movies. The reality is worse. The low pressure would cause the gases in your body to expand. Your saliva would boil away. And the lack of oxygen? You'd be unconscious in about 15 seconds. But here is the chemical kicker. What is that atmosphere made of? 95% carbon dioxide, nearly 3% nitrogen, and only 0.13% oxygen. So, even if you could breathe the thin air, it would be like sucking on a car exhaust pipe. To live on Mars, we don't just need a warm coat. We need a machine that creates air 24/7 for the rest of our lives. The cold, beyond Earth's limits. Okay, so we have the air problem. Next up, temperature. Mars is cold, really cold, but it's not a consistent cold like your freezer. It fluctuates wildly because the thin atmosphere can't hold heat. At the equator, during summer, the ground temperature might reach a pleasant 20 degrees Celsius or 70 degrees Fahrenheit. Sounds almost like San Diego, right? Don't pack your shorts yet, because at night, that same spot plunges to minus 73 degrees Celsius or minus 100 degrees Fahrenheit. That's a temperature swing of nearly 100 degrees in a single day. For comparison, the coldest recorded temperature on Earth was around minus 89 degrees Celsius. Mars hits that every night in most places. This thermal shock is brutal on materials. Metals expand and contract. Electronics need constant heating. Living on Mars means you're not just building a house, you're building a fortress that has to survive a daily cycle of extreme heat and extreme cold, all while maintaining a livable temperature inside. Radiation, the invisible shower. Now, we get to the really nasty part, the part you can't see or feel until it's too late. Radiation. Earth has a magnetic field and a thick atmosphere that act like a giant shield, deflecting cosmic rays and solar wind. Mars lost its magnetic field billions of years ago. Without it, the surface is constantly bombarded by radiation. NASA's Curiosity rover measured the radiation levels. The average astronaut on the International Space Station gets exposed to about the same radiation as a worker in a nuclear power plant. On the surface of Mars, you'd get about 40 to 50 times that amount. Spending just 1 year on the surface of Mars would expose you to roughly half of your career-long safe limit for astronauts. If you tried to live on the surface in a simple tent or a thin-walled module, you'd be cooking your DNA. The risk of cancer would skyrocket. To survive, your habitat needs heavy shielding. That usually means burying it under meters of Martian soil or living in lava tubes deep underground. So your nice house with a view of the red landscape? You might never actually see it without a thick layer of rock above your head. Gravity. The withering effect. We've covered the environment outside, but what about the environment inside your body? Mars has about 38% of Earth's gravity. That's 1/3. We know from astronauts on the ISS what low gravity does to humans. It's not pretty. Your muscles atrophy. Your bones lose density. Your spine expands, making you taller, but weaker. Fluids shift to your head, pressing on your optic nerves and damaging your eyesight. On the ISS, astronauts exercise for 2 hours a day just to slow down the decay, and they still come back weak. On Mars, we don't know if 1/3 gravity is enough to stop that decay, or if it just slows it down. There's a real possibility that children born on Mars would never be able to visit Earth because their bodies would be too weak to stand up in our gravity. You might survive on Mars, but you might become a permanent resident, physically unable to leave. Soil and water. The toxic dust. Okay, so we need to live underground in heated, pressurized, shielded habitats. But we also need resources. Water and food. The good news is, we've found water ice on Mars. Lots of it, buried under the surface. We can melt it, filter it, and drink it. The bad news is, the soil, or regolith, is full of toxic chemicals. Specifically, Martian soil is loaded with perchlorates. These are chlorine-based chemicals that are poisonous to humans. They mess with your thyroid. If you tracked this red dust into your habitat, which you inevitably would, it would contaminate everything. It's like walking in a field of asbestos mixed with bleach. So, if you want to grow food, you can't just plant a potato in the Martian soil like in the movie. You'd have to wash the perchlorates out of the soil or use hydroponics, growing plants in water. It's possible, but it turns farming into a high-tech chemistry lab. The psychological toll. Now, let's talk about the mind, because even if your body survives, your brain might break. Imagine living in a small, underground module. You can't go outside without a spacesuit. If you do go outside, the sky is pinkish-brown. The sun is just a tiny dot, and there are no trees, no animals, no sounds except your own breathing. The nearest other human is millions of kilometers away. A message to Earth takes up to 20 minutes to send and 20 minutes to get a reply. Isolation experiments on Earth, like in Antarctica or the HISEAS habitat in Hawaii, show that people get depressed, anxious, and irritable. They develop sleep disorders. On Mars, there's no coming home for the weekend. You are committed for years, possibly for life. The success of a Mars colony depends as much on psychology as it does on engineering. So, is it possible? So, after all that bad news, let's answer the title question. Is life on Mars possible? The scientific answer is, technically yes. It is physically possible. We have the technology to build shielded habitats, to extract water, to generate air from the CO2. There's a device on the Perseverance rover called MOXIE that proved we can turn Martian air into oxygen. We can grow food hydroponically. But here is the catch. It's not life as we know it. It's not moving to a new continent. It's more like moving to an extreme research station in Antarctica, but 1,000 times more dangerous. The first Martians won't be colonists. They'll be professional survivors. They will live like cave dwellers, reliant on machines for every breath they take. It is possible, but it requires us to accept that Mars will never be Earth. It will always be a hostile, alien world that tolerates us only as long as our machines keep humming. The big gamble. So why do we want to go? If it's so hard, why bother? Because Mars represents the ultimate backup drive for humanity. If something catastrophic happens on Earth, an asteroid, a nuclear war, a supervolcano, a self-sustaining colony on Mars would ensure that humanity survives. It's an insurance policy for our species. The question isn't really whether we can live on Mars. We can. The real question is, are we willing to pay the price, take the risk, and endure the hardship to make it happen? What do you think? Is living in a cave on a cold, red planet worth the future of humanity? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.